You were the first one to clone p53 gene. Why this contribution is so important to fight against cancer?
So we know that cancer develops through changes in many genes, but of all those genes, the gene that is most frequently changed in cancer is p53. And more than 50% of all cancer patients have mutations in the p53 gene, which results in the loss of the protective activity of p53. The normal function of p53 is to protect us against cancer. Therefore, it's called a tumor suppressor. And when the gene becomes defective, this defense mechanism is lost, and the door is opened for a normal cell to become cancer cell. And because of this centrality of p53, it was important to clone the gene, because without the gene we cannot study any modern function in a real way. This is now the first step for any gene that we care about. You have to clone the gene. Once you can clone the gene, you can manipulate it. You can add it to cancer cells and see what happens. One thing that happens, for instance, is that you put a normal good p53 gene into cancer cells that have a defective p53 gene, and they commit suicide. So the restoration of good p53 will instruct cancer cells to commit suicide, which is, of course, what we would want always to see in cancer. If all the cancer cells committed suicide, we will all be very happy.
I wanted to ask you about the first step to develop a cancer. What does it make the cells to self-destroy?
In each cell in our body, there is a built-in self-destruction mechanism. This is part of becoming a multicellular organism. The simple organisms are one cell, and the whole thing they care about is to be alive and multiply. The body is like a community. The cells have to work together, and if they don't work together and they try to be individual, this is what cancer is. Mm-hmm. So in part of becoming a multicellular organism, rules, just like in a civilized society, there are rules of things that you can do because they are good for the society, and there are things that you cannot do because they are bad for the society. And becoming a cancer cell is bad for a society. And some other things that cells can do when they don't do what they need is also bad. So in each cell in the body, there is, in multicellular organisms, there is a suicide mechanism, which of course is suppressed as long as the cell is behaving correctly, but can be activated once this cell becomes dangerous for the body. And p53 is responsible to a significant extent for controlling this suicide mechanism, and it activates it when a cell tries to become a cancer cell.
Mm-hmm. And what is the biggest challenge for all of you, for the researchers against cancer right now?
The biggest challenge right now is to deal with the complexity of cancer. We know for a long time that cancer is not one disease. It's many diseases, and with modern technology, we see that in fact there are even more variations of cancer between individual patients, and even in a single patient there are different types of cancer cells. So it's not like one disease, one virus, you treat, you cure. So we need to deal with the realization that each person has a different individual cancer, and find ways in which we understand how to target the cancer of each individual patient, and to develop enough tools, enough drugs, enough compounds that will allow us to target as many varieties of cancer as possible. So I would say again, the challenge of cancer now is the challenge of complexity. Cancer is very complex, very heterogeneous, and if we want to cure cancer, we have to cure many different cancers, not one cure for cancer. That's it.
Mm-hmm. Are we approaching toward a more personal and preventive medicine?
Definitely yes. I already hinted that, and the good news is that we now have much better tools to characterize each patient, each cancer. We have now very advanced genomic tools in which we can get a huge amount of information about from each tumor. We have very good bioinformatics tools to interpret this information, and this is the way that will lead to personalized cancer medicine. The limiting factor will become, do we have enough medications to treat all these different types of cancer?
Are you referring right now to the supercomputers, big data?
Big data, yes. So big data in cancer research, in the side of research on cancer, the major challenge is to be able to interpret big data. We now can generate, we already can generate big data, very big data on cancer, because the methodologies, the technologies are very advanced as a result of the Human Genome Project, which started this revolution in genomics. I think the biggest benefit from that has been in cancer research. But the ability to take this huge amount of data and compress it to a simple message, this is what you need to do to this patient, this is a challenge which is still people are still fighting with, and it needs experts that are not classical experts. An oncologist doesn't know how to do it. We need computer scientists. We need a different type of experts that can now move cancer research forward.
Mm-hmm. And what is the most important thing that we can do to avoid suffering cancer? Or anyway, is writing in our genes and we are predestined to suffer it?
So we know that cancer is not just an accident, and it's not something that is just written in our genes. It's a combination of both. It's different people come with different genes, and different people will have a different chance to develop cancer or different types of cancer. So part of it is in our genes, but most of it is in what happens after we are born. How we live, how we experience our environment, diet, exposure to chemicals. So we can do a lot to reduce cancer. And the area of cancer prevention is one in which much more can still be done.
Mm-hmm. And are you agree about how viruses and bacteria are the cause of 21% of cancers?
I don't think that we can take, for any study in medicine, I don't think we should take numbers as solid, because you can look at 3 studies, they ask the same question, they even get the same answer but different numbers. So 21%, I don't think that 21% is a holy number. But there's growing recognition now that bacteria contribute both to cancer development and perhaps also to cancer resistance to chemotherapy. In fact, one of the lectures that is going to be presented from the Weizmann Institute during the symposium specifically talks about how bacteria interfere with cancer therapy. Bacteria inside the tumor prevent the tumor from responding to cancer therapy. So this is a world that has opened to cancer research quite recently, understanding how the microbiome affects cancer, and there's much more to be learned also in this area.
Mm-hmm. Can we say that now is the best moment to work in alliances, to work connected with other institutions?
It's not, I wouldn't say it's the best moment, I would say it's inevitable, because the challenge of cancer is very big now, and if we don't work together, we cannot do cancer research the way that was done 50 years ago. Small laboratory, 5 mice, you do some experiments. We have to work together, because the nature of the research now is that it has to be, many people come together with different expertises, and you know, Spanish cancer, Israeli cancer, American cancer is the same cancer. So it's stupid not to work together, and I would say it's even a crime not to work together.
Mm-hmm. And what do you expect about the new relationship with the Centro, Nacional de Investigaciones Oncológicas?
I hope that it will develop to important collaborations. We have many common interests. We have a common goal of making cancer vanish eventually. We have a shared goal. We have a lot of areas of that are either similar or complementary. So I would very much like to see extensive collaborations, and the more, the better.
Thank you.